So in lesson 2, what we're going to do is we're going to take those Boolean statements that we talked about in lesson 1, and we're going to tie them together with what are called conditionals. And in doing so, we will actually be able to make a decision in our program and make something happen differently depending on the input that the user puts into the program. So our goal by the end of lesson 2 is that you can meet the following learning target, and that's that you can use a conditional if statement in your Python program. So not only explain to me what it is and how it works, but actually use it in a program to make something happen and to solve a problem. So as I talked about in the previous lesson, this entire chapter focuses on this concept of decisions and the fact that we want our computers to respond differently depending on the user's input. So what we'll do in the second video of this particular lesson is we will actually create this grades program together, and the student will enter in their grade, and then the computer will either spit back a congratulations message saying, hey, congrats, you passed the course, or it will send back a sad message that says, unfortunately, you did not pass the course. And so it'll all depend on what the student or the user enters in for their grade. So in the previous lesson, I talked about flowcharts, and this is actually a flowchart of an if conditional. So what's happening here is this diamond represents a decision that is taking place, and an if conditional, as it's called, takes in a Boolean statement. And these are called conditionals because a condition needs to be met. And what will happen with just this simple decision if conditional is there's a condition that'll go inside of your if statement, and we'll talk about that syntax on the next slide. But what will happen is you'll have a condition that's sitting here, and if that condition is true, some actions will occur, and we'll designate where those are to our program and say, if this statement is true, run this code. If this statement is false, it will skip all of this and instead move on to the next action that is past that if conditional. And we'll talk about that as we look at the code for the first time on the next slide. So this is an example of what an if conditional looks like in Python code. So anything that's here in black has to stay. So you'll notice you have the word if. That is a key part of that conditional. It's a reserved word that's reserved for this specific purpose. And then this colon right here signifies that it's the end of a Boolean condition. So what happens here is we have these two statements in blue that can be changed, and it depends on the needs of your program. But you will write a Boolean statement and it will go right here. And this is what condition needs to be met in order for your code to run. So you will put a Boolean conditional in here, and what your program will do when it sees this word if is it will go in and it will evaluate this Boolean condition. And if this Boolean condition is true, so if this is true, it'll run whatever statements you have here that are indented, okay? So it will evaluate the Boolean statement, see if it's true, and if it's true, it runs all of the code that's contained inside of that conditional. So notice that this in here, this condition has to be a Boolean statement. It must be something that evaluates to be true or false. The other thing to note here is that these statements here may or may not run. It depends on the results of this Boolean condition. If the Boolean condition is true, these statements will run. If the Boolean condition is false, what your program will do is it will actually skip all the way to below the if, and it will not run those statements and will keep going. A couple other key details about these conditional blocks are that this colon is actually very important. So you have to have this colon at the end of your Boolean condition. If you don't, your program is going to throw an error because this signals to your program that it's the end of a Boolean statement and that it should evaluate whether or not it is true. Then this indent right here, anything that you want to only run if this condition is true needs to be indented here. So this indented code, however many statements you have that are indented, will only run if the Boolean statement is true. Otherwise, it will be completely skipped. And then down here is a key asterisk, and you'll see this as we code together. When the code is no longer indented, so when we are no longer indenting statements, That's when your program knows, hey, this if conditional is done, I can now move on and keep running every line of code like I was before. So if you look in your notes, the next thing you will see is that there are 6 segments of code, and they are all if conditionals. And what I'd like you to do is take a look at them and see if you can decide whether or not those segments of code are valid or invalid. And if you think it's invalid, try and identify what the error might be. So pause the video for a second, look at them. Some of them contain errors, some of them do not, and see if you can figure out if it's valid or invalid code. So hopefully you attempted those 6, and if you look here on the screen, you'll now be able to check your work. So the only 2 that were actually valid were D and F. In letter A, we were missing those colons after your Boolean statement. Those are important. They need to be in there in order to communicate that the Boolean statement is done. In B, this is what we wanted to run if this statement was true, but it's not indented. And with no indented portion, there's really no purpose of this if statement because it's not deciding whether or not to run code. So this would actually need to be indented for this to be valid code. In letter C, remember we talked about those equal signs and how a single equal sign is different than a double equal sign. And a double equal sign talks about equality. Are these 2 sides equal? And it's for Boolean statements only. The single equal sign is for assignment. So that's going to assign a value to a variable. So we need to have a double equal sign in here for that to be a Boolean statement. Then if you look at D, that line of code is valid. Nothing wrong with it. That's just a not equal to symbol. In letter E, if you look at X plus Y plus Z, if you're adding things together, they probably have to be numbers. And if you're adding numbers together, this is going to produce another number. That's not actually a Boolean statement. Whatever is in here needs to be Boolean. It needs to evaluate to be true or false. So not having that in there, if it's just a number, that's not something that an if statement can actually make a decision on. And then in F, this last one, I know the parentheses might make it look a little bit different, but this is actually valid. The parentheses don't make it wrong. Just the user might like the use of parentheses to enclose it and make it really pop that X is equal to 50 or 60, is what we're checking. So the last thing I want to model for you is this concept of tracing code. And we will do that a lot in this class because it shows me that you understand how to read code. So what we're going to do is we're going to trace them through. You'll notice I have all 3 variable names over here on the left. And what we're going to do is we're going to trace through them and say, okay, what happens to X, Y, and Z as the program runs, and then what type of output or things are we printing to the screen. So I'm going to go through line by line, read the code, decide what runs, what doesn't, and trace it over here on the right-hand side. So the first thing it says is X is equal to 2. So X starts off equal to the value of 2. And then Y is equal to -5, and Z is equal to 16. So I've checked off these 3 lines of code. Then I come to this conditional, and I need to decide, is this conditional true or false? Well, here, X times Y, X is 2 and Y is -5. That's what I can see. And X times -2, -2 times -5 is -10. And -10 is not equal to -10. This is a true statement. So what that's telling me is that this, in fact, is going to run. So then what happens is Y becomes X times 2. So because this line of code runs, Y is actually going to change value. It's no longer going to be -5. Instead, it's going to be the value of X, which is 2, times 2, so Y becomes 4. And then we move on. We've checked off these lines of code, and we move on to here. And it says, if Y times Y is greater than 16. Well, here I know that Y times Y is 4. So this is saying 16 is greater than 16. And I know that this is a false statement. So what that's telling me is that this conditional, it's not going to run at all. So Z, this line of code, never runs because this statement is false. So then we skip to the bottom and we're going to print to the screen, and that's where our output section comes in. And we're going to print that the x value, which is 2, the y value, which is 4, and the z value, which is 16. So that's what tracing looks like. We're just going through, we're tracking the values of our 3 variables that we have, and then we're showing what will output to the screen anytime we have some print statements.